Hi everyone, my name is Brandon Peruano, and I'm excited to share my final project for engineering analysis and computation. I created a terminal based earthquake simulation that models tectonic stress across a two-dimensional surface. This program is interactive, visual, and reactive as it updates in real time based on user defined fault lines. I built this in C and it challenged me to apply concepts such as multidimensional arrays, structs, ANSI color codes, and simulation logic all in one cohesive project. Let me start by walking through how the simulation works at a high level. When the program launches, users are prompted to create fault lines. These represent areas where tectonic plates meet. They can draw lines and even circles using terminal input. Internally, I mark these fault line points inside a 2D array called B. Once fault lines are drawn, the user types -1 to begin the simulation. That's when the magic starts. Each point in the 2D grid begins accumulating stress. If it's on a fault line, it gains random amount of stress between 0 and 10. If it's not on a fault line, it loses or gains a small amount between -5 and 5, but it never drops below 0. This means that fault lines accumulate stress more quickly, just like in real life. I use color coding to show different stress levels. Green for low stress between 0 and 49, yellow for medium stress between 50 and 99, and red for high stress for any value over 100. When any point hits 200 or more, it triggers an earthquake at that point and ends the simulation with a visual highlight. Let's dive into the code that powers this simulation. First, I defined a simulation data struct that contains two 2D arrays, A for stress values and B for fault line locations. This separation helped keep things organized. In the create fault lines function, I allow users to input various shapes. To render circles, I implemented Bressenham's circle algorithm, which draws symmetric, pixel-perfect circles even in a grid-based terminal. Then we move on to the simulate stress function. This function drives the main simulation loop. I iterate over every point on the grid. If a point is on a fault line, I add a random value between 0 and 10 to its stress level. Otherwise, I vary it by -5 to 5 and clamp negative values to 0. To create a visual effect on the surface refreshing, I clear the screen using system CLS and then reprint the grid with ANSI escape codes for color. When a point reaches 200, I use a special display, red text on a yellow background and a big earthquake banner at the top. Overall, the logic simulates how stress accumulates and how fault lines play a crucial role in triggering seismic events. Let's take a look at the simulation in action. First, I'll draw a fault line, in this case, a circle right in the center. Now, I'll start the simulation by typing -1. You can see the grid refreshing every second. The stress levels are constantly updating and changing colors as they rise. As this goes on, you can start to spot areas that are heating up, turning yellow and then red. Finally, an earthquake is triggered once a point hits a value of 200 for its stress, and the simulation ends with a final warning display. This project taught me a lot beyond just syntax. I now feel comfortable working with 2D arrays and structs in C, which are fundamental to system-level programming. I also learned how to create interactive terminal apps that respond to user input and provide visual feedback using ANSI color codes. One of the trickier parts was handling edge cases, like avoiding negative stress values or rendering shapes near the edge of the grid. Debugging alignment issues and stress accumulation logic taught me how important testing is, even for small visual details. And most importantly, I saw firsthand how simulation software can model real-world systems like tectonics in a meaningful way. Overall, this project brought together a lot of different programming concepts into a single cohesive application. From user input to real-time simulation, data structuring, and colorful terminal output, it challenged me to be both creative and analytical. I'm really proud of the result and I had fun building it. Thank you so much for watching.